Hello, good day viewers. Someone requested that I should show that cosine of theta is equivalent to sine of 90 degrees minus theta. So in this tutorial, I'm going to show you two different ways to prove this. Let me start with right angled triangle. So suppose we have a right angled triangle like this. You know this angle right here is 90 degrees. Let this angle be theta, that is our reference angle. And let this one be alpha. Okay. Let this be y, the side length. Let this be x, and let this be r. First of all, I would like to take cosine of theta. Cosine of theta. Remember the ratio. Cosine of theta is the ratio of the adjacent to that of the hypotenuse. So we have x divided by what? Hypotenuse, r. So what if you want to find sine of alpha? What would that be? You know that sine is what? Opposite divided by the hypotenuse. If you're talking about this angle, this is directly opposite to that angle, which is x. So opposite of that angle is x. And hypotenuse is always the hypotenuse, which is r. So just observe x divided by r, x divided by r, which implies that cosine of theta is equal to sine of alpha. Cosine of theta equals sine of alpha. But why is it possible? Let us examine something. Remember that the sum of all angles in a triangle equals 180. And already we have 90 degrees here. Therefore, the sum of these two angles must be 90 degrees as well. And we call them what? Complementary angles. All right. Alpha plus theta must be 90 degrees. Alpha plus theta must be 90 degrees. So what if we decide to make alpha the subject? We can take theta to the other side. We have alpha equals 90 degrees minus theta. And since we have an alpha here, we can replace it with 90 minus theta because we have alpha to the left hand side. This implies that cosine of theta is equal to sine of 90 degrees minus theta, and hence proved using right angle triangle. And this is always true. Sine of an angle is equal to cosine of an angle if and only if the sum of their arguments will result to 90 degrees. Just observe, if you take this argument, you add it to this one, you're going to obtain 90 degrees. So this is always true. So the second approach is by the use of double angle identity. So we have to prove that cosine of theta is equal to sine of 90 degrees minus theta. So I would like to take the right hand side and show that it is equivalent to the left hand side. So from the right hand side, we have that sine of 90 degrees minus theta is what we have, right? So what I would like to remind you is about double angle. Sine of, for example, x plus or minus, because it could be plus or minus y. This is equal to sine of the first angle multiplied by cosine of the second angle. You see the first angle is x, the second angle is y. Then plus or minus again. Then this time around, we're going to take sine of the second angle multiplied by the cosine of the first angle. So this is what we have. If you have plus here, please use plus here. If it is minus, you use minus. But since we have minus, we are going to apply minus. So let me do the same thing, apply the same thing to expand this. Therefore, sine of 90 minus theta, for which x equal to 90 and y equal to theta, we have sine of the first angle, which is 90 degrees, multiplied by cosine of the second angle, which is theta. Then because we have minus, I will use minus. Then this time around, sine of the second angle multiplied by cosine of the first angle, which is 90 degrees. So let's simplify. You should know that sine of 90 degrees is equal to 1. So we have 1 multiplied by cosine of theta minus sine of theta multiplied by cosine of 90 degrees is 0. So you can see that the whole of this will give us 0 because sine of theta times 0 is 0, and 1 times cosine of theta is cosine of theta. And hence, the whole of this is nothing but cosine of theta. And hence, we have just shown that sine of 90 degrees minus theta is equivalent to cos of theta. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.